In this video, I'm going to show you how to graph using transformations. And I would ask you to go through the concept map, which reads transformation in your modules. And it's better to have that document opened when you are listening to this video. Okay, the order in which I like to do the transformation is if there is reflection, then do that first. Now, again, both in the horizontal or vertical direction. The next option would be if there is stretch or compression, do that next. And the last transformation must be the shifts. Okay, if you do the problems in this order, then you will definitely not have any problems. Okay, so one of the first thing in graphing this function is identifying the basic library function, and in this case they already gave it to me. It is a square root function. The graph you see here is the basic library function, which is the square root function. Now I would like to go in a coordinate level transformations, so I am going to pick three key points from this basic library function. So one would be 0, 0. The other one, to deal with easily, I'll call it 1, 1, because 1, square root of 1 is also 1. The next number I'm picking is 4, square root of 4 is 2. The next number, if I would have picked it, would have been 9, because square root of 9 is 3. But I think this 3 would be enough to do the transformations. Okay, so this is the easy way to understand how these graphs are transformed in a coordinate level. What is happening to each of the coordinate when there is a specific type of transformation. Please watch the transformation video before listening to this. The how transformation works and all there is attached in another videos. Okay. The next thing is I'm looking at this a given transformed graph, and this is what I am supposed to graph. And now I need to identify the transformation. So here there are two transformations. This 1/2 is telling me there is a vertical compression by a factor of half, and the next transformation I'm seeing is this +1, which is giving me there is a horizontal shift of the graph 1 unit to the left. Again, these informations, you can watch that concept map documentation attached, and I have explained it and written it clearly there. How do you identify a horizontal shift? How do you identify, vertical compression and so on? Okay. So any vertical transformation, the coordinates that get affected is the y. And if there is a horizontal transformation, the coordinate that gets affected is the x. So again, the order I'm following is there is no reflection in this problem. So the next one I'm going to do is the stretch or compression. I'm seeing a vertical compression. So that will make my basic library function transformed into f of x is equal to 1/2 square root of x. So this half, because it's a vertical transformation, it's a vertical compression, and this half affects my y coordinate of the key points. So what I will be doing is the effect would have been multiplying half to the y coordinate. So 0, 0 times 1/2 would be, let me use another color, so 0. So then nothing happens on the first one because you're multiplying half to a 0. The second transformation is 1 comma to this 1. If I multiply a half, it would becomes a half. And the third number would have been 4 comma. If you multiply half to 2, it would become 1. Okay, so this particular transformation is the vertical compression. Now to this points where I transformed using vertical compression, I am going to do the horizontal shift. So that would make my graph, my function g of x, again this is g of x, sorry guys. It's not f, it's g. Okay, so g of x is equal to half square root of x plus 1. Now this plus 1 is a horizontal shift. So the graph is being shifted to the left 1 unit. The effect on the coordinates would be the x coordinates would change. Therefore, my y coordinates would stay the same. So let me use this. So y coordinate would stay the same. So that's still going to be 0. The second point is still going to be half. The third point is still going to be 1. But the x coordinates are going to be changed. And the effect is you will be taking the 1 and subtracting it to the x values. So I have a 0. 0 minus 1 is negative 1. Next number is 1. 1 minus 1 would be 0. And the third point would have been 4 minus 1, which is 3. So this is the points of the transformed graph. So the first coordinate is, so this point 0, 0, this point 0, 0 will now become negative 1, 0. This point 1, 1 will now become 0 and a half, so somewhere there. So this point 4, 2 would have become 3, comma 1. So what I'm drawing in red is the transformed graph of the given basic library function f of x is equal to square root of x, which is a square root function. I hope you understood this. Again, I have 2 more example problems on this document, which will be the next 2 videos.